I guess we're looking at week 12. This week we have lesson 108, 109 for one day, and then 110 for the other, which means we are nearing the end of this unit. We'll obviously do the review after 110 and get ready for the test. So let's go ahead and flip over to 108 with our first lesson. So we are looking at formulas and substitution. So again, a formula is just something where we have area equals base times height, or area is length times width, or distance equals rate times time. So this is just a formula that we know that we're given. Okay? And if we have two unknowns, or three unknowns, three variables, and we're given two of the three, we can solve for the missing one. So if we're given distance, d, and rate for 9, we can just plug in, and well, distance is 36, 9 is the rate. What's the time? Well, we're just going to get t by itself, and we're going to end up with 9t equals 36. We divide both sides by 9 to get t equals 4, or 4 equals t. Again, we usually put the variable on the left and then the number values on the right. But it's 4 equals t and t equals 4 is the same thing. So if on a test, I'm obviously not going to mark you wrong if you have the t still on the right side of the equal sign. Because they'll probably rewrite it just for consistency's sake. We can rearrange these formulas also. So we'll use the distance equals rate times time. We can manipulate this, so to speak, or we can rearrange it so that way we have it in terms of d, which we already do. We divided both sides by t, where we get r equals distance divided by time. If we do not want it in terms of rate, we could do it in terms of time and divide both sides by r and get t equals distance divided by rate. So time equals the distance divided by the rate. So there are, write our original, so we're going to have to erase everything. So we have 1, 2, 3 ways that we can write the same formula. It's just what are we given? If we're looking for rate, we probably want to jump straight to this one. We don't have to. We could plug in here and use inverse operations, but if we know these three are equivalent, we're given the rate and time and we want to know the distance, we'll use this one. We're given the distance and the rate and we want to know the time, we probably want to use this one right here. They're all the same formula, just manipulated and rearranged so that way we can write it in terms of whatever we're looking for. This one, I believe I've let you guys write on your reference sheet. If you don't have it, you want to write it right now, you can put F equals 1.8C plus 32. That's when we're finding Fahrenheit and we're given Celsius. Some formulas, they use 9/5 instead of 1.8, but it's the same thing, so you can use it either way. So we're going to use this formula and we're going to find when C is 37 or equals 37. I'll go ahead. Fahrenheit equals C, which we're going to put in 37 plus 32. Make sure I put down quickly. 37 degrees. So we plug in that, and this is where when we put in 0 for Celsius, 1.8 times 0 is 0 plus 32. That's why in Fahrenheit, our freezing is 32 and not 0. So that's what's kind of, I guess, interesting is we can have like 10 degrees. It's below freezing, but it's still not a negative temperature in Fahrenheit. So below 0 in Fahrenheit is different than below freezing. But that's just a little side note. So we put this in, we got 1.8 times 37 plus 32. 1.8 times 37 plus 32 is 98.6 degrees. So that's where Celsius and Fahrenheit obviously very different. You know, someone's calling you from another country, which I think the United States is only one, there may be one or two other countries that I'm not aware of, but I think they're the primary country that uses Fahrenheit, whereas most of the rest of the world uses Celsius. So if they're like, it's 37 degrees, you're probably going, ooh, not too warm. What's going on over there? And then you think, oh, 37 degrees Celsius, that's actually a pretty hot day. Because if we call it 98.6 degrees, most of us would think that's a pretty high temperature. So we plugged in Celsius to get Fahrenheit. Again, that's just a formula that we're given. All right, we'll look at some of these formulas that they probably look familiar. Area is base times height. Area equals 1/2 base times height. The Fahrenheit one we just told you. Again, we can use either 1.8 or 9/5, either way. Okay, we'll go over that together. And then we're looking at lesson 109, equations with exponents. Right, so we have, for example, store. 3x squared plus 1 equals 28. So what we're going to do, so just like our one-step problems, our two-step problems, our three-step problems, we want to think inverse operations to try and get x, or a, b, c, whatever it is, on its own. We want to isolate the variable. We want to get x by itself. So first thing we can do is we can minus 1. I do it to the left, I have to do it to the right. 1 minus 1 is just 0. 3x squared plus 0, just 3x squared. 28 minus 1, 27. Now our coefficient is 3, so 3 times x squared. I'm multiplying, so I can divide. X squared equals 27 divided by 3, which is 9. So I end up with x squared equals 9. Now, yes, the opposite of square is to take the square root. Square root is 3. But for this, we may have, actually for this one we're definitely going to have, but for future reference, you may have some problems where you have more than one solution. So we need both of them. You can't put one of the two and say, well, I got one, so I get the full thing right. No, you need to have both of them to get full credit. So if we look back here, well, 3 squared is 9. That is true. So positive 3 works. Also, we could put in negative 3 and square it, because negative 3 times negative 3 is positive 9. So we actually have positive or negative 3 that would work for this. So I just put it like this. You can put x equals 3 or x equals negative 3. I just think using the two symbols makes it a little bit easier. So that way we just save time versus having to write it out. So we did everything and we ended up with the 2 here. And if we put in 3 or negative 3, it works out to be true. We have a problem where we have more than one solution. That's okay. That's right. So I'll just, obviously, if you see an exponent of 2, there's a good chance that you're going to have 2 solutions. So just be aware of that. If we have cubed or a negative, or something negative, an odd exponent, then it's going to be either positive or negative. This goes back to the negative times negative is a positive times a positive is a positive. So we just have to be aware of that. Okay. If you have an exponent of 4, which we won't see any of those, or 6 or 8 or anything like that, we're running into the same deal. If we look at 3x squared minus 1 equals 47, we're going to add 1 to both sides to get rid of that. And we'll divide by 3, and we're going to be left with x squared equals 16. We know the square root of 16 is 4, but is there any other numbers we can put in for x to make this true? Yes, there is. We can put in positive 4 and negative 4, because negative 4 squared is 16. So we put this in our original. Negative 4 squared is 16 times 3 is 48 minus 1 is 47. So it still works out to be true. But just make a mental note of that. We'll go over it on the review when we see it. I'll make sure we emphasize it so you guys remember. But when you see that on a test, this exponent of 2, and you're trying to solve for an unknown, think right away, okay, there's probably going to be two answers that I need to have. And it's just positive or negative 5 or 3 or 4 or whatever. It's not like you're having to start over and solve it twice. You just have to realize that. Like for this example, 4 squared is 16 plus times 3 is 48 minus 1 is 47. But also negative 4 we could put in for x and work out to be true. So now if we have 2x squared equals 10, again, inverse operation, so I'm multiplying, so I want to divide. 10 divided by 2 is 5. Take the square root. Okay, on both sides, that gives me x. And what can I do? Positive or negative? Well, let's take a look. Let's use our calculator. We'll do 2 times the square root of 5 squared. That equals 10. About 2 times, I use parentheses just to make sure I don't mess up. Hold on. And that equals negative 10. So let's make sure we did it correctly. So, why is that? Oh, I see what it's doing. So, let's just start at 2 times. Oh, okay. Oh, I gotta have it. Right? Parentheses on both. Alright, anyways. Let's do it this way. Square root of the calculator is not wanting to recognize the order of operations correctly. So we'll square it. We'll do negative square root of 5 times square root of negative 5. Okay, that's positive 5 times 2 equals 10. So that's where I said sometimes your calculator with the parentheses and the negative signs, just be aware. Obviously, 5, the square root of 5 squared and negative square root of 5 squared should both be positive 10. So if you're getting something that isn't making sense, it's something in your calculator, it's doing a different order of operations than you're expecting it to. Because yes, this one, even though they're both irrational, we still do get two solutions, 5 and negative 5. Now the negative symbol needs to be outside of the radical sign because we can't take the square root of a negative number. We will down the road when you guys get into high school, you'll have what's known as imaginary numbers, which is super fun. And you can take the square root of -1 and break it apart, but we're not going to even get into that right now. So don't put the negative sign under the radical sign. It's outside. Let's look at example 4. If this figure, the area of the larger square is 4 square units, which is twice the area of the smaller square, what is the length of each side of the smaller square? Okay. We're going to use S to stand for the length of each side of the smaller square, so the area is S squared. Since the area of the larger square is 4, it's twice that of the smaller, so the area of the smaller square is 2. It was 4, and it was twice the area of the smaller. So side squared equals 2. So we take the square root of s squared and 2, and we get s equals square root of 2. Now in this example, why we do not also include the square root of negative 2 is because for distance, again, distance we think of absolute value, like whether we're going north or south or heading to Denver or back from Denver or whatever it is, anytime we're talking about lengths or distances, we don't use negative numbers. So I can't go draw a square and measure negative 2 inches or negative square root of 2 inches or centimeters or feet or whatever. So we don't use this in some real world examples because it just doesn't make sense. So side length can be the square root of 2. It's irrational, so we'll just leave it as that. So that is our answer. Or if you have something like this, x over 3 equals 12 over x. Okay. We could sit and try and figure out, oh, what can it be? That's going to be the same value here as here. Or we could remember what we talked about, cross multiply. X times x is x squared. 3 times 12 is 36. So we know we can cross multiply. The cross products have to be equal for the fractions to be equal. Okay? And then we take the square root. Okay? Gives us x equals 6. Or it could be also negative 6. Negative 6 over 3 is 2. Or sorry, negative 6 over 3 is negative 2. 12 over negative 6 is negative 2. 6 over 3 is 2. 12 over 6 is 2. So they would both be equal, whether it was positive 6 or negative 6. All right, so we'll look at these when we return. Okay, and then the last one we're looking at for this week is simple interest, compound interest, and successive discounts. Okay, we have different types of interest. Again, if it's our money that's growing, we want the higher interest rate, and we want compounded interest if possible. When it's money we're paying back, we want the lowest amount of interest as possible. So we don't want to pay back any more money than we have to. We take out loans, different things like that for cars, homes, college, whatever. We're going to pay it back over time, but we're going to pay back more than we originally borrowed because we're going to have interest on top of it. So the difference between simple interest and compound interest, simple interest is paid on the principal only and not paid on accumulated interest. If you deposit $100 into an account, 6% simple interest, you get 6% of 100, which is $6. If you take your money out after 3 years, you've made $6, $12, $18 because you're making $6 a year. So it's 6% on the 100. Okay, year 1, 2, 3, you now have $118. 18 extra dollars. So yeah, that interest rate, 6% would be not terrible. That's a pretty good return on investment. But, with inflation and things like that, probably isn't going to keep it. Most interest-bearing accounts, however, are compound interest accounts, not simple interest. So compound is good when it's our money. In a compound interest account, it's going to go up, but it's going to go up not at the principal after quarterly or the year, whatever it is, annually. It's going to now be the new starting point, and it's going to take the percentage off of the new principal. So $100 at 6%, the first year would be the same. We made $6. But now we're at 106, and you're taking 6% of 106, not 100. And so this is our new starting point. We're taking 6% of that. 112, 0.36, we take 6% of that, that's $6.74. So you say, big whoop, okay, we made 118, and this one we made $119.10. $1.10 isn't that big of a deal. But if you're talking about, instead of $100, maybe $100,000 or $1 million or something like that, and you're talking about instead of 3 years, 30 years or something like that, this is going to be a substantial difference in how much you're making. And we look at this amount that we have. Again, year 3, big whoop. It doesn't really matter. Yeah, for 3 years at $100, it's not that big of a deal. But after 10 years, it's still not that big. But compound is kind of that exponential growth. It's not just going up at a linear rate. Oh, now we're almost $100 more for 20 years. Again, I'm not going to retire on a $100 difference, but you could apply this to more time, higher interest rate, or a bigger starting principal, and you could see how much it would make a difference. After 30 years, there's our difference. After 40 years and after 50 years, you can really start to see over time, you can really start to see the advantage of compound interest versus simple interest. Make a table that shows $1,000 investment growing at 10% compounded annually, which means every year after 1, 2, 3, 4, 5 years. So 1,000 at 10%. So 1, 2, 3, 4, 5. Pay 10% of 1,000. So how we could do this in a calculator. We know 100% is equal to 1. So if it's going up by 10%, we have 1,000 times 0.01, or sorry, times 1, so 0.10 for 10%, which is $100. And then we could add that back to our 1,000. An easier way than that is, since we know 100% is equal to 1, well, we can multiply it by 1.10 or 1.1 to get the same thing. So 1,000 times 1.1, because this is 110%. If it's going up 10%, it's going to be 110% of the original. So this is year 2, times 1.1 for year 3, times 1.1 year 4, times 1.15, and continuing on. So that's an easier way then. Bring out 10% of this, add it back to where you were. 10% of this new amount, add it back to where you were. And you can do it that way. It's just, if you're calculating something for 30 years, it's probably going to be easier to do this. We can also use exponents, 1,000 times 1.1 to the power of whatever the number of years. So let's say it's 10 years. 1,000 times 110% of 1.1 to the power of 10, because this is going to count for year 1, year 2, year 3, because it's going to multiply it by itself 10 different times. Okay, so there we go. So we got all those numbers where we have 1,100. 3 was 1210. 4 was 1331. 5 was 1464. Oh, and we didn't do year 5. It was this number times 1.1, which gives us that number. So again, simple interest, well, 10% of 1,000 is 100. So simple interest would go up by 100, 100, 100, 100, 100. We'd be at, what would that be? 1,400 would be up, or 400 we'd be at after 4 years, and 500 after 5 years. But we're obviously much more than that. We started at 1,000, now we're at 1,610.51. And this is showing you how we can use the exponent key, which I just showed you. Use a calculator to find the value of 12 years. After 12 years of an investment, 2,000 and 7.5 interest compounded annually. So let's first write down what we did. So 2,000 principal. 12 years is our time at 7.5. We first got to make this into decimal 0.075, well, we know 107.5% is be 1.075. Because 1 is the 100% where we started at, and then we're going to multiply it by this to show the growth. We're going to do 2,000 times this being our 100% plus 7.5% or 7.5%. We just made it into a decimal, and then we're going to raise that to 12. Let's see if we get the answer. We'll do it both ways and see if we got the same thing. So let's clear this out. So we get 2,000 times 1.075. 1.075. You can see how it's going to take. Oh, and see, we already missed the number. I already messed that up. So you would not want to work today. So we can keep doing that, and for 12 years, or we can go back and say, okay, I know 2,000 is my principal. Times every year it's going to be 1.075 of whatever the starting point is. So I can just do that and raise it to the power of 12 because that's my number of years. So I'm going to end up 4,763, and we round to 56 cents. So we were given that. 4,763 and 56 cents. So again, money, so we round to 2 decimal places to make life easier. All right, let's look at example 4. An appliance store reduced the price of a $400 washing machine 25% when the washing machine did not sell. So this is a successive discount we're looking at. We find a percent of a percent. So again, just like multiplying a fraction by a fraction, like half of half is actually 1/4. It's going to be the same thing with the percent. We're taking a discount off of a discount, basically. So an appliance store reduced the price of a $400 washing machine 25%. When the washing machine did not sell at that price, the store reduced the price 20% to its clearance price. What was the clearance price of the washing machine? So we start at $400, and it went reduce the price 25%. So we don't multiply by 0.25, we're multiplying it by 0.75, because if it's 75% of the original rate, it's 25% off. And then of that, we're going to multiply it by, they reduced another 20%, which means it's 80% of this new sales price. And so again, percentage ones, just make sure you read it carefully and then make sure you convert it to decimals. We don't want to multiply by 75 and make it much larger, which doesn't make sense for a sale. So $400 times 0.75 times 0.8. And we get $240. Because again, it's 80% of this new price, not 80% of 400. We took 75% or 25% also, 75% of the original, and we took 80% of that new price to get to $240. And we'll do the practice set together. Okay, that's it for this lesson. We'll start reviewing in class and go over that together. Make sure you pay attention for that. So we'll see you guys in class.